Can you see the paint?
Yes, sir.
Yes, sir.
So the second case is, you remember?
Compound microscope.
No,
Infinity.
far point.
Infinity.
Compound.
You need one more adjustment in simple microscope. Image formed at far point. So far point means
Infinity.
infinity. So how to get the image formed at infinity?
Object at the focus.
Yeah, thank you. Object at focus. So you can draw the diagram. Lens, principal axis. You mark center of the lens as C. F. The other side also F. This distance should match, okay, exactly. Otherwise, there will be a problem in this case. C to F.
Yeah.
If you take 2 centimeter on the left, again 2 centimeter on the right. The object has to be at the focus.
Yeah.
The object. You can give the name OP. O is same as point F.
B.
So C to O will be the focal length, right?
Yeah, C2 is the focal length.
Yeah, that's the object distance. That is even the focal length.
Yes.
And as usual, first light ray will go parallel.
Passes through the focus.
Better I'm not drawing that. If any mistake, I can adjust focal length. Okay, so I'm drawing the other one next. Because if it didn't mark, I didn't measure it. Something wrong with me, I can adjust focus. So this is central light ray. And you know the light ray will be parallel, right? At infinity.
Yeah.
So this light ray should go and become parallel. That's correct. If you measure correctly, it will become parallel without any adjustment.
Yes, sir.
So light rays, arrow mark is compulsory. Otherwise, you lose half mark for the boards. Okay.
Yes, sir.
Okay, sir.
Since the light rays go straight, you can even extend the light ray back. Final image is formed at infinity.
So is it necessary to have two arrow marks, like before convergence and after convergence?
Every light ray
Yeah.
need to have one arrow mark before the lens and one arrow mark after the lens. Every light ray.
Okay, sir.
Okay.
Yes, sir.
And the diagram is done. Then you have to go for the magnifying power. As per the definition, magnifying power is you remember yesterday we had a long
Theta O by theta I.
theta.
O by theta I.
Normally always
Theta
we
I by
Theta
compare
I by theta O.
image
theta I
with
by
respect to
theta
the
O.
object. Always, okay.
Yes.
Always we compare image with respect to the object. Now you need to find theta O and theta I. How to find theta O?
Sir, OB by OC?
Uh, see, when you find theta O, there was
So it's
something
not
very.
So add 25.
so in the previous question, so just like will magnification be V by U or U by V?
Which one?
In the previous question,
Yeah, previous question.
U by V or V by U? The
V by U.
yeah, okay.
Yeah, V by U only. But we changed V by U into another formula.
Yeah.
Yes, sir.
Yeah.
So I didn't get you.
It was not the final result V by U in the last case.
No,
It
you.
was 1 plus D by F.
Yeah.
Okay.
See, I want theta O in this. Which angle?
Triangle BCO.
Okay. Still, I don't know. You forget one important point when you do
Add
theta O
25.
at
25 centimeters.
25 centimeters. This is a length which is very small, focal length.
Yeah.
So it won't be 25 centimeters.
We need to take the object to 25.
Yeah, correct. So yesterday, like I've drawn, I'm drawing another diagram from here, C. I can draw over this diagram itself, okay? Bringing the object from O to the near point. This is the object. And we draw the angle at the eye. I'm giving the letters like that. O becomes O dash. B becomes B dash. Then this point is still same as C. And this angle is known as
Theta O.
theta O. What is C to O dash distance?
25.
T.
Yeah, 25 centimeters, or we write as a symbol capital D. Then how to find theta I?
The image is formed at infinity. So from there, we can take BCO again.
Yeah. Even yesterday we had a big image. We didn't take with respect to the image. We taken the small triangle only.
Yeah.
So this is a light ray coming from the image. That makes an
Yes.
angle at C. So this angle will be theta I.
Yeah.
So that you can get from the small triangle. You don't want the real image. You only want the light ray from the image.
Yep.
So how
Yes,
do we
sir.
determine the light ray of the image?
Sorry.
So how do we know which light ray we have to use to
How many light rays we have now in this?
2?
Where the angle to be subtended? When you find theta I and theta O, where the angle to be subtended?
So BCO.
Who is viewing the image and object? Just try, no issues, it's fine.
Mhm.
The object and image is for the human eye, right?
Yes, sir.
So the angle should be subtended at the
Object.
Siddharth? Hello.
Yes, sir.
Yeah, Siddharth asked me a question. He's not responding now.
Yes, sir.
Sorry, it's my got muted.
Yeah, it's okay.
No, yes, sir.
So the image and object is for the human eye, right?
Yes, sir.
So the angle to be subtended at the human eye. And
Yes,
for
sir.
microscope and telescope, we always take eye to be the center of the lens. Here, eye is just behind the lens. So C is the position where we need to subtend the angle.
Okay, sir. Got it. Yeah.
Which light ray pass through C? Only one light ray, right?
Yes, sir.
This angle. So I'm waiting. If any confusions, after that only I want to move. I just don't want to finish it off and go. You're okay, fine. Otherwise, tell me what, why.
It's okay, sir.
You understood why BCO is not theta O?
Yes, sir.
Why?
Yes, sir.
So because FC, the distance is not the near point. It's not 25
Yeah.
centimeters.
That's a important point. When you find theta O, the object should be always at.
25 centimeters.
25
Otherwise,
centimeters.
you should transfer for finding theta O, the object to 25 centimeters. Okay.
Yes, sir.
Yes, sir.
Then how to find theta I?
So using the image light ray, we have to take the triangle that's formed,
Yeah.
and then from the angle take the given sides.
It is not compulsory the image should be there. You can have a triangle other than
The
the
light
image
ray.
triangle also. That light ray is enough.
Yes, sir.
Is it fine?
Yes, sir.
Yes,
Then
sir.
go M as what? Tan
Theta I by
Yeah.
tan theta O.
I divided by tan theta O. Check what comes.
B dash O
So
dash by
BO, yeah.
C O dash divided by BO by C.
BO by OC.
Tan theta I. Once more you tell me, I didn't listen to you.
B dash O dash.
Tan theta I, no, first.
Yeah. Tan theta. Okay, sorry. BO by CO.
Yeah. BO by CO.
Into
Divided by
F.
B dash O dash by C O dash.
Yeah, you can make it into like Siddharth told. That's better. One step you can say. Will come
Yeah,
as
okay, then CO dash by
CO dash.
CO dash
O,
by
O dash B dash.
Yeah.
O dash B dash.
O dash B dash is the same.
Yeah,
Cut
O
that.
dash B dash is same as
OB.
OB.
OB. So it gets cut and finally it comes as
C dash O dash by CO. CO
D by
CO
R.
dash
C O dash
by
by
CO.
I see you.
CO.
we substitute the values, you get the answer now. Done. What is C O
D
dash?
by R.
Yeah.
D.
D.
25.
D.
By
Which,
F.
yeah.
If you apply sign convention, both are negative, right? C O dash is negative, CO also negative.
Yeah.
Yes, sir.
So
Yes,
it
sir.
will become positive.
So it will remain positive. Yes.
Yeah.
So
That's
here
it.
D is 25, right?
Every time D is 25 if they don't give the value, okay?
Yes, sir.
The D value is 25. Can you compare the last case and this case? This is for near point. I mean far point.
Last case, it's
1 plus
one
D by
more.
F.
For
So it's 1 unit more.
yes. So for
Near
near
point.
point, the formula was M is equal to
1 plus D by F.
D by F. So what is the option for increasing the magnifying power of a simple microscope?
So short focal length.
Yeah. So decreasing or using a short focal length. That's better, not decreasing. Once made, you can't change.
Yeah.
Using short focal length. convex lens.
So does it have to do with the aperture of the lens, like for
No,
increasing magnifying
aperture
power?
don't decide the focal length.
Also, for increasing the magnifying power,
Yeah,
does it depend on the aperture
yeah.
for a simple microscope?
Aperture don't decide the focal length. There only one factor has, right? Focal length is the
Going
Like
Okay, fine.
no other
is the
terms
main
in the
magnification.
yes.
Yes, sir. Yes, sir.
Using short focal length convex lens, magnifying power of
Can be
simple microscope can be increased. So you can't say inversely proportional, okay?
yeah,
Because there's a 1 plus factor here.
yeah,
Inversely
that's right.
proportional means it should be just d by f. Here only you can say decreasing the focal length will help to increase the magnifying power. Fine.
Shani sir, what if we used LCM and made it f plus d by f?
Okay, but f is there in the numerator then, no?
Yeah, so then it's still not
Yeah, still not.
okay.
This case you can see what far point.
Yeah,
Yes, sir.
that's
Directly you can see.
inversely proportional.
Yeah, it's inverse. But wherever extra plus minus comes, you can't say inversely proportional.
Okay, sir.
Yes.
So this is a simple case. If you understood, it's not even that long compared to the last case to change the formula into a different format.
Yeah.
So when you get the image at far point, you told me
When
very
we keep
quickly.
the object
Yeah, object at the
focus.
focus. When you get the image at near point,
when the
Keep
object
the
is at infinity.
I didn't hear properly.
So when the object is between the center and focus.
Yeah, it's fine, right?
Yes, sir.
Yes, sir.
Yes, sir.
Now we are thinking of another option where you can get higher magnifying power. So the only option here is if you use one lens, you have to use short focal length lens.
Yes.
So for short focal length lens, you need to use large curvature. Like the lens become much thick. I don't know, you've seen some specs, people having thick lenses like.
yes, sir.
Yeah.
So if the lens become so much thick like this, the lens act like prisms. Like here, the prism almost. Top is a prism, down is another prism. So the light can undergo dispersion. Dispersion means
Yeah. Breaking of like dispersion means separation of white light into 7 colors.
yeah. So you get so many images for a white object if you keep.
Yeah.
So it's not easy to increase the magnifying power by
Increasing
Short
the
focal length
thickness.
lens.
yeah. There's a limit. If you go beyond that limit, it will lead to problems. So what we
Yes,
do,
sir.
we learned before starting the optical instruments on topic. When you combine two lenses, the total magnification is product of the individual magnifications.
Yeah.
Yes, sir.
M is equal to M1 product with M2.
M2.
So we are going to use two lenses so that without any other defect, you can get what higher magnification.
Yes, sir.
It's like
Yes, sir.
chemistry concept, element and compound, symbol and compound like. Wherever more than one lens is used, we call it as compound.
Yes, sir.
So it's called next topic, compound microscope. There also we have two cases, image formed at
Near point, far point.
Infinity.
Near point and far point.
far point. So can I leave this and go if you're fine?
Yeah, it's fine.
Yes, sir.
Yes, sir.
Fine,
It's
sir.
fine.
So we have the principal axis. We have two lenses. We'll keep the first lens first. This lens is kept near the object. So because of that, this lens is called
Objective.
Objective lens.
objective lens or simply objective. This is the center of the objective lens. This is C1 because there's one more lens going to come.
Yes.
C1. Now we have to keep a second lens through which we see the final image. Yes.
Yeah.
Island.
That's called eye
Lens
lens.
or eyepiece lens.
Eye lens or
Eye
eyepiece. Okay. So the here image formation is two-step.
Yes, sir.
First, yeah. Tell me.
So first, when the image is formed, in the case of the objective lens,
Yes.
the image formed for the objective lens will be the object for the eyepiece lens. But the important thing in that is the image can't be with the eyepiece lens. It has to be at 25.
Yeah, it's little. I think sound is little less audible.
Yeah.
Oh, sorry, sir.
Thank you.
So can
Yeah.
you hear me now?
Yeah, yeah.
Yes, sir.
Make it clear.
So the image for the objective lens becomes the object for the image lens.
Yeah.
But the most important point in that, which you mentioned before, was that it has to be at 25 centimeters.
Okay. So I'm just marking f of the objective lens. There are two methods. One, you can draw the diagram from object to the image. This is second method. You can draw back image to the object. Object to the image, you need to fix all the focal length. Image back to the object, you don't want to fix anything, it will come naturally, only to fix the image. Okay. I'll show you the normal one first. I will show you the normal one first, and if you want, I'll go for the image back to the object.
Okay, sir. Yeah.
So equal distance on left and right, I'm keeping F. Okay. Now, where the object should be placed for the first lens.
So which case is this? Near point?
Yeah, but first lens doesn't make a difference in that. If the second lens is deciding where the image to be near point or far point.
So beyond F,
Yeah, why beyond F?
so that we can get an image at F for the second for the eye lens.
If you keep within F, the image is formed on the same side, right?
Yes.
sir.
So the light rays should be highly diverging.
Yeah.
So you need a large size lens on the other side if you keep within the focus.
Okay, sir.
It's better the first lens forms a magnified and inverted image by keeping beyond F. Then that can act as the object for the eye lens.
Yeah.
So first we are doing near point, okay? Image at near point. So I'm keeping the object beyond F is the object. So OB object. B. So what is C1O?
Object
C12.
distance.
U.
U.
Yeah, U for the,
Objective lens.
Objective lens.
I can write UO. Fine.
Yeah.
Now, as usual, two light rays. One light ray
Parallel to the principal axis.
Passes through focus.
will pass to the focus, and second light ray will pass to the center to form the image. Yeah, this is a problem. This is, I told you, the other method is fine. Which method?
From image to object.
Yeah. So I can adjust by drawing this one first, and the focal length I can adjust slightly to get the image. Yes. So this is the focus point, okay?
Yes.
Now this is the image formed by the first lens. I prefer the other way. You draw the diagram because that will not make any mistakes, but it learns something different. That's it. So this I am calling it as I1, I1, F1, because this is the first image formed by the lens. Then this will act as the image formed by the first lens. Objective lens act as the
Object for the eyepiece.
Object for
for
the
the
eye
side.
lens.
Then if you want to get the final image at near point, what you should do now?
So bring it to 25.
Now that is the image. You should tell me where the object should be kept for that. Now I'm going to keep a second lens. Where should I keep the second lens?
So where do we want the image?
It's written image should be formed at near point.
Near point.
Uh,
So the object should be placed at near point for the eye lens.
See, your aim is to not get the image formed by the first lens to be at near point. The second lens should form the
Second
image at the
lens.
near point. This lens should form the image at near point, and that only the eye will be seeing, human eye.
Yes, sir.
So beyond that,
Oh, that is why I asked you last question before I start with this topic. You remember how to get the image at far point and near point?
So we have to put the lens at FO, like on the right hand side.
We have to put the,
I think we have to put the lens at the second FO.
no. That will give you an image at infinity.
yes.
So I think we have to put the, wait. So I think you have to put the lens between C1 and FO.
See, my question is, who is forming the final image?
Eye lens.
eyepiece lens.
Yeah, that's called eye lens, right? Not human eye, okay?
Yeah.
This eye lens. So where you want this lens to form the image?
At 25
At near
centimeters from
point.
the eye.
Yeah, so where you keep the object for that lens then?
Between F and O.
Yeah. This F is called FE.
Okay. Eye lens focus.
Yeah, so I should bring the eye lens in such a way this image formed will,
Form an image at your point. At 25.
yeah, means that image will be within the focal length of this lens, eye lens.
Yeah. Okay. So
Okay.
so the image is formed behind, right?
Yeah, image is formed behind, that's okay. That
It
image
has to be virtual, right?
see that one you don't worry. Why you it has to be virtual? Okay, my question is virtual, real. You don't mind. You tell me where the object should be placed to get the final image at 25 centimeters.
So
Between
between
FE and
FE
C2.
and C2.
Okay, I'm changing the question just for understanding. If I want the final image at far point,
Yeah.
And the focus.
Should be at FE.
yeah. So the,
The
image
focus, yes.
formed by the first lens should be at the focus of the
Second lens.
second lens, means eye
Yeah.
lens.
Yeah.
That's the point I was asking you from the beginning now, where you keep the object for the second lens. Yes?
So I had a bit of confusion for near
Yeah.
point. Far point it was fine. But yeah.
Okay. If C2 focal length is 10 centimeter, imagine C2 focal length is 10 centimeter. And
Yes.
where I1 should be formed, I1 M1.
For what? Near point or
For
far
this
point?
case, near point, yeah, near point.
For near point, it should be formed less than 10 centimeters. That means between F, E, and O.
FE and
C2.
O. C2, yeah.
C2. So I'm fixing the focal length here, this point focal length as here as FE. So
Okay.
if this is FE, the image is within the focus, right?
Yes.
The same FE on the other side also. Yes.
Yeah.
Now you can follow the old rules again. How to get the final image?
Parallel to the principal
Parallel.
axis passes through the focus.
Yeah.
And
unlike
one through the
present,
optical center.
I always draw through the optical center first because the other way I have to adjust sometimes.
It can be adjusted here.
This is the light ray passing through the optic center. And second light ray has to go parallel. Then it has to pass to the
FE.
focus to get the image. Now you can see these light rays are diverging. So we should extend them
Backwards.
yeah, to get the final image. Go like this. This also you have to extend. So I don't get the image.
So it's okay. So you can just it's
Oh.
understood. You can continue.
But it won't work for the exams. You have to have an image.
Yeah, in exams we'll have more space, right?
Yeah, that's why I told you I prefer always from what?
Image to object.
Image back to the object. You understood how to draw this way?
Yes, sir.
Yes. So I
Yeah.
can retry the other way.
Alisa, in this case, we don't bring it back to 25.
Which one?
So in
No,
the
because it's
second
formed
case,
at near point.
the island. In this case, we don't have to bring it back to 25 centimeters.
What do you want to bring to 25?
So the object for the eyepiece lens.
Why you want object
No,
with the
why?
eyepiece to be 25 centimeter? This
We
is
want
the
image
object
at
to the
near
eyepiece.
point.
The question is not object to the near point. Image should be at the near point. Which image?
Eye lens
Image formed by islands.
The final image. Okay.
Yes, sir.
It has to be final image, not the first image. The final image has to be at the near point. So that means where this is meeting, that point will be the near point. If I draw a line here to the image, this image is formed at near point, but it's not correct. So I'm going to redraw the diagram other way.
Okay, sir.
So this method is fine, you can try, but no guarantee always it will come.
So I tried, so I didn't get it.
Sorry?
So I got it.
It can come. I can make it come. That I can adjust, no issues in that. But I want to tell you it may come like this. We have seen so many times invigilation time, The students will try to draw, rub, redraw. The diagram go out of the page even in an exam paper. Still they can't get in the paper. And they finally what they do
The
now,
should-
they will bend the light ray and adjust like this, and draw the image here. That never accepted. Okay, like this.
So it should be formed at the focus.
What
No,
should be
at
formed at the
25.
focus, Siddharth?
So like the final image
What's on the top I have written?
at near point.
Yeah, then how it can be at the focus?
Okay.
We have two adjustments for a microscope. One is image formed at.
So I meant as FO. Should it be formed at FO?
No, why?
No, that's for
That's by
if image
chance
should
it
be
comes.
formed at.
That is wrong, I told you. It's not correct also.
Okay.
It won't be formed at FO. It will be formed even behind this. Why? 25 centimeter is far away. You have
So,
two lenses of short focal length. Yes.
Yes, sir.
Yes, sir.
Even you add the focal length, it won't come 25. So it will be formed behind this somewhere. So because of this difficulty, I want to show you this is little hard to draw. You can get it, no problem. You can adjust the lens position, focal length, and you can get. So I'm going back to the other way diagram. Okay.
yeah.
The case is compound microscope, final image at near point. So first here what I do, I draw the principal axis. I'm fixing both lenses. The lens 1 is here. The lens 2 is here. I think your second lens has to be little large in size compared to the first one.
Yes, sir.
Yes. Then I'm keeping the final image first. Okay. This is a final image. Yes.
Okay.
This is a final image. It will be formed at 25 centimeters because near point.
So 25 centimeters from C2.
From C2, from the eye. This eye, right? Here is eye.
Okay.
So this point is what? C1.
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 Yeah. And this point will be
C2.
C2.
C2. And this is a final image. And this will be, Siddharth, you asked, it's virtual. Okay.
Yes, sir.
You can check how I'm doing this. This is called IM. It's I and M. I'm drawing one light ray from M to C2. Drawing one light ray from M to C2. Yes.
Yes, sir.
Yeah.
And second light ray, I'm deciding something. The second light ray starting from M itself, but I'm taking a point below C2 here. Yes.
Yes, sir.
That you can decide. That point will decide the height of the image formed by the first lens. So I'm fixing a point here. I'm drawing second line from here. Same point M. It's passing through.
Focus.
And see a point below C2 here. Yes.
Okay.
So I can adjust this. If I don't have a space here, I can make it like this or like this as per the space, my convenience. Okay. That's the importance.
So within that light ray,
Sorry.
it doesn't follow any rule, right? Like parallel to the principal axis, passing through the focus or something.
Yeah, it will follow. You can see that this is the other way we are drawing. We are not following the rule. It will follow the rule finally.
Yes,
Yes.
sir. Yes, sir.
Now I'm drawing all backward. Okay. Now I will draw another line from this particular point parallel to the principal axis.
Okay, yeah. Yes, sir.
It's following the rule now. See, parallel will pass through the focus.
Yes, sir.
This is actually the extension of that. These two.
Yeah.
But I've drawn that first.
Yes, sir.
Now I'm drawing the image. This is the image formed by the first lens, which is the object for this
Yes.
lens. I don't know now it makes sense or not.
Yes, sir. Makes sense.
Yes, sir.
This is the object for the second lens, which is the image
Lens.
formed by the first lens. Now you can understand this light ray is passing through the center, no deviation, right?
Yes, sir.
Yes. And
Yes,
this
sir.
light ray is passing through, is passing parallel and passing through the focus.
Focus. Yes, sir.
So that's why I told you I don't want to fix focus. Now we can write clearly what this point where the parallel light ray meet is what?
FE.
I don't want to fix anything. I just want to fix the height of the image and the height of the object for the second lens.
Yes, sir.
Fine. Now I can rub this all dotted. Why? This is the extension of the light ray.
Yeah.
Yes, sir.
This is like my advantage. I can fix in any size. Whatever the availability, I can fix the image there. Okay.
Yes,
Yes,
sir.
So, but then, so won't they check for the image formation of the objective lens, sir?
Sorry.
So, won't they check for like the image formation of the objective lens?
Yeah, we'll see
I
the
we just
objective
draw
lens. We'll see what happens.
Sir, M1, sir.
Ah, sorry. Okay.
M1.
Yeah, M1 correct. I don't know if you feel this easy compared to the other one. If you got an idea, this is the best one.
This
So
is much
this is more
easier.
accurate.
Yeah, you
Yes.
can get it within fixed
Yes,
size. Never you go wrong.
You
Yeah.
don't have to adjust anything per se.
Yeah. Now I'll follow the same rule for this lens also. Remember what I did here? From M,
Yes.
one light ray was passing through C2, right?
Yeah.
Now from M1,
Passing through C1.
one light ray will pass through C1. Right? And from M1, second light ray again will pass through one point here, but that again I'm deciding like here, how much height.
Yeah.
Here I decided a height. Here also I'm deciding a small height because it has to be small. Okay. I will
Yes, sir.
take this height to be less than this height, this particular height. Okay. So the second light ray from here will meet somewhere here. Then here I made it parallel, right?
Yes, sir.
Here also I'm
Parallel,
going
yeah.
to make it parallel. Like this. So now this is the actual object. I don't mind you follow any method. I just want to avoid any inconvenience of getting the diagram out of the paper. That's it.
Yes, sir.
Shani, sir.
Yeah.
Yes, sir.
Sir, how do we get the focal length the
Yeah,
same?
I'll tell you. You got the focal length of FE right here.
Yeah.
Yeah, same will tell you. 1 minute. I'm just completing this. So this is the arrow
So
mark.
because for the objective lens, they don't look the same. The focal length.
No, it's not. This is not focal length.
That's not okay. Sorry. Yeah.
Okay, now tell me how you find the focal length of the lens. Parallel light ray should pass to the focus, right?
Yes.
Yes, sir.
This is a parallel light ray, it should pass to the focus. This point should be the
Focus.
FO,
FO.
focus of
objective lens.
Objective lens.
with scale, measure the same distance and mark here also. It will be here. Mark C1 to F4, how much? Same here also. Fine.
So we will get like decimal points, right? Maybe it will be
It's okay,
1.7.
just
I got like
adjustment.
1.7.
Fine.
Yeah.
But if it's
It
equal,
doesn't
it's
matter. Yeah, no one will go to measure and check how much you get in that. But almost should be the same. Okay.
Yeah.
It will be decimal point, no doubt in that. It can't come exactly 2. Sometimes it comes.
Okay.
So now the diagram is clear, right?
Yes.
I got exact 2.
Yeah. Then what is this distance?
U1 or
U.
UO.
UO.
O. And what is this distance?
VO.
Yeah.
VO.
And what about this distance?
UI or UE.
U of the eye lens. And where is the image formed?
At D.
Yeah.
Yeah. So what is this distance like?
D.
D.
But it's called as image distance, right?
Yeah.
Yes, sir.
So BE.
BE
V is equal to D.
equal to D.
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 Is it fine now?
Yeah.
Then I marked FE on the right hand side, right? She says C2
Yes, sir.
FE.
Yes, sir.
Yeah.
Measure same and mark on the left hand side also. It will come same. Like the image will be within the focus of the lens.
Okay.
I'm marking here F. So C2 to FE left and C2 to FE right has to be same. I prefer this, up to you, whatever you get. Okay, no problem in that. I don't have any issue in that. But this is guaranteed. It will come sure. Other one also you can make sure if you take some precautions. If this is fine, this lens is known as
Objective lens.
Objective lens.
and the other lens is
Eyepiece lens.
eye lens. Then we need some properties for the objective lens and eye lens. You can see one from the diagram itself.
Objective lens is smaller than eye lens.
Yeah. So objective lens is of small aperture. For objective lens, you can put as properties small aperture. What about the focal length?
Small focal length.
It's a short focal length.
Yeah, because already we know to get magnified image, you need short focal length.
Yeah.
Yes, sir.
Small aperture and
Short focal length.
short focal length. Then eye lens.
Large
I don't
aperture,
say
large
large
focal.
because
Compared to objective lens.
yeah, these all very small objects like normally you see in biolab, the onion cell, leaf section, virus, bacteria, or small objects will be formed not that much large magnified. Okay,
Yes, sir.
so eye lens also has to be even small aperture or medium aperture,
But large
Larger than the
compared to
objective.
larger than the objective. That's it. That to cover the image form. Okay, larger than the object. Yes.
Yeah.
Focal length again has to be short.
Larger.
Sure.
Short focal length, but still,
Larger.
yeah,
Larger
FP has
than
to be slightly
objective lens.
greater than F. Both has to be short and small, but slightly greater compared to the objective lens. Now we have to go for the magnifying power. For that, you have to identify what is theta I and theta O.
Theta I will be
Where is the image? This image, right?
IC2M.
IC2M. Okay, so this is theta I.
Or we can take I1 M1, I1 C2 M1.
Yeah, you have two options. But anyway, the triangle will be this. I mean, the angle will be this, right?
Yeah.
Yes.
Okay. And what is theta O?
Theta O will be
Theta O only, you have to be careful.
I1 C2 M1. No.
So
it will be
BC10.
IC2
Theta
M1.
O should be with the actual object, not the intermediate object, the first object.
So BC10.
B, okay, there's a B, right? Yeah.
Yes, sir.
You remember, it has to be a near point. Still, you don't take care of that point. It is not at the near point. Why the image is formed at the near point?
So you transfer the object to near point.
That's it. That's the first point you think before when you find the angle for theta O every time.
Yes, sir.
Shani sir, are we taking we are taking in respect to C2, right?
Because all with respect to C2 and object, nothing in between. Okay.
Right.
The object is a first object and image is a final image, not intermediate ones.
Yeah.
Because we are comparing the size with respect to the final image with the first object. Okay.
Yes, sir.
Okay.
So how to find theta O?
Take OB, take the object to I.
Yeah, I'm drawing a line here. I don't have space down. So this is the D, right? Same distance.
Yeah.
Then the object should be transferred to that point. Object is transferred here. Then you draw the line from C2 to that point.
Yeah.
So this
That'll
point
be
I still mark as O dash. And this point is B dash. And this angle will be
Theta O.
Theta O.
Theta O.
I don't know, still you feel confusion for theta O and theta I.
So it's fine.
So then go for the derivation. What's the step? M is equal to?
Theta I by theta O.
Yeah. Theta I divided by theta O. Okay. Then next step will be
Tan theta I by
Tan theta by tan theta.
and theta I.
Shani sir,
Yes.
is it necessary to write that first step theta I by theta O?
Yeah, because
or can we
we are
continue
doing
with
4 or
tan
5 times, it's okay. We can understand. But exam only one question will come.
Oh, okay.
So then that time we have to mention, right? You can't leave it like that.
Okay, fine, sir.
So then you have to go to the diagram and find what is tan theta I and tan theta O.
I am I1
I1
M1
M1
by
by
I1
I2.
C2.
Right. Yeah, I1 C2.
I1 M1 by
I1 C2.
I1 C2.
I1 C2. Then
So
And
B
into
dash O dash by O dash C2.
okay.
yeah, but that distance is D, right? This one.
Yes, sir.
That is V
The
B dash O dash
equal to
by D.
minus 2. So you can take that I1 M1 by C2 I1. Okay, I'll go for that. So fine. Okay. So tell me M is equal to tan theta I first.
So I1 M1
Yeah, I1 M1
by
divided by
M1 C2.
C2
C2 I1.
C2
I want
I1.
C2.
Okay.
Yeah, C2.
C2 I1 Then
Tan theta O is B dash O dash
yeah. So you can
by
reciprocate, right?
minus D.
Yeah, O dash C2.
C2 O dash, right?
Yeah.
Yes, sir.
C2
Yes, sir.
O dash by
By O dash B, B dash.
O dash B dash.
So can we cancel I1, M1 and O dash B dash?
No, you can't.
You
Which
can't do
one?
answer.
So can we cancel I1, M1 and O dash B dash?
No,
I1
one is the object, the
M1
other
is
one
not
is
same
image.
as O dash B dash, right?
Okay, sir. Yeah.
Which one you transfer to this point? You transfer this only. OB is transferred to this point. So OB same as O dash B dash, not I1 M1. Okay.
Yes.
So if I rearrange this with a particular purpose, I'll get M is equal to I1 M1 by O dash B dash can be OB, right?
Yes, sir.
Yeah. I1 M1 by OB. Then what is left?
C2 O dash.
It won't come like that. I can't write like that. I1 M1 by OB.
So where is O dash in this figure?
O dash is here.
No, in the figure, in this figure.
This figure on the top.
No, I don't want that figure. I want the other figure.
Then
This
it will
one
be I.
down.
It will be same as I then.
It'll be same as I.
Yeah, because we are bringing the object to the near point.
Yes, sir.
I don't
So
draw
theta.
here because if you draw a line through this, it will feel like complicated. Like
Yes, yes.
that's why taken out.
So O dash is the I and B dash is M.
B dash, it's just same height as B here.
Yes, sir.
B dash is nothing, no other point. It's a separate point.
Okay. Got it, sir. Got it.
So you asked some question just now.
Yeah.
So what is the question?
I now what is the next part of the left derivation? The right, the second term of this.
So we can write C2 O dash as
Yeah,
D minus D.
C2 O dash
So minus D.
C2 O dash by
I1,
O
C2.
dash.
C2 I1, right?
Yeah.
Yes, sir.
Okay.
C.
Now C2 O dash is what actually?
D.
Yeah, but I'm writing VE. That will give last, okay?
Okay, sir.
Then what is C2 I1?
C.
It was marked here. That's gone in the diagram now.
So
So
you.
UE.
Yeah. So I'm substituting like that, okay?
Yes, sir. So minus, right?
Yeah, minus all I'm not giving now. Anything. Like all will last one will give, okay?
Yes, sir. Yeah.
What is I1 M1 by OB? Height of the image by height of the object, right?
Yes, sir.
No?
Yes, sir.
So I can write as what? Magnification of the objective lens. Yes?
Yes, sir.
Then product with C2 O dash by C2 I1. That is V by U, right?
Yes, sir.
That's again magnification of the eye lens, right?
Yeah.
Yes, sir.
ME.
Yeah. ME.
So M is equal to M1 into M2.
Yeah. This is what we derived there again, last chapter, last topic. M1 into M2. Yes?
Yes, sir.
Now I'm giving MO as UO by UO. Is it fine with you?
Yeah.
Yes, sir.
Yes, sir.
Okay.
Yes,
The
sir.
last step. One more step is needed. C2 O dash is VE by UE. I didn't give last step because I want to introduce that MO into ME. That's why. Yes.
Yes, sir.
Now, if you observe the second lens, it acts like a simple microscope, right? Check the second lens, only the second lens.
Yeah.
Only the second lens,
Yes, sir.
object and image, right?
Yeah.
So it is the one of the case we have done before, last simple microscopy case.
Image at near point.
Yeah. So what was the result for that?
1 plus d by f.
So VE by UE I can do like that.
Yeah.
Do you follow?
So V is d, right?
Yeah. So you remember last case we taken that and 1 by V minus 1 by U we multiplied by V and we proved it as 1 plus D by F.
Yeah.
Yes, sir.
So you can do if this much here like, but it's too long. We can just write directly.
Okay.
So I'm taking
VO
this to
by
the
U
right.
to 1 plus V by F.
Yeah, I'm just taking this to the right and writing a sentence since I lens act as a simple microscope, otherwise to derive, okay, forming.
So we can write this for the boards.
Yes,
What do we need to do?
image at here point. Since the islands act like a simple microscope and forming the image at near point, what you can change V, V by UE, V
Yeah.
by UE, which is same as MO, ME, can be
It
taken
will
as what?
become 1 plus d.
1
1
plus
plus D by FE.
D by F. If you're
Yeah.
so particular in deriving, you can sit and derive. I don't mind, up to you. But this is enough for the board.
Okay.
If it was forming image at far point, it was just 1 by just D by Fe. We derived
V by
together.
F. Yes.
Okay.
Now we substitute, that's a final answer. M is equal to VO by
U
UO.
into 1 plus d by f.
Yeah. 1 plus D by F. We apply sign convention. VO is positive, UO is negative, right? VO is towards
Yes.
right and UO is towards left against the
Yeah.
right. You can have a minus
Yeah,
sign
yeah.
here. That minus is for UO, okay?
Okay.
But numerical questions, we don't use that much for the magnifying power. Or what's the meaning of negative sign?
Inverted.
Yes.
Inverted image.
So that you can write here, negative sign indicate
Inverted image.
final image is inverted with respect to actual object, the first object.
Yeah. Shani sir,
Yes.
can I go to the washroom, sir?
Yeah.
Okay.
If you're done, I have one more approximation. Last, this much is enough for the exams and numericals, but it's an approximation we do to get a rough idea about the magnifying power.
Yes, sir.
What is the length of the microscope tube between C1 and C2? Length of the tubes.
So VO plus UE.
Yeah. L is equal to VO plus UE. It's not an approximation, because you need to know for the numerical questions. The approximation comes just for understanding a rough idea about the magnifying power. So what you do, you just take F4. It's almost same as U. The object can be brought very close here, very close. So you get a magnified image. So F4 is approximately equal to UO, or you say UO is approximately equal to F4. Means I'm going to change UO as F4 and LS approximately equal to BO. It's not correct, it's just an approximation to get the final answer with constants. So if you go for M, then what will come? If you do that changes. I'm just putting magnitude, no sign. So it's equal to
L by U.
UO.
L by FO.
Yeah. L by F4. Then the right part no change. No change. 1 plus D by F. It's only approximated result we never use for the calculations.
Okay.
You can check and tell me any confusions.
So how is L approximately equal to VO?
You take that as an assumption.
Yeah, but we write L is equal to VO plus UE.
Yeah.
So then how, then do we take UE as
I
0?
think it's supposed to be VE.
Which one?
So how is
So-
L approximately equal to VO?
L is from C1 to C2, right?
Yeah.
And the first lens is forming image within the focus, right?
Yeah.
We have shown this large to get the diagram clear, okay?
Okay.
So this will be forming very close to the lens, actually, practically.
So are we taking UE as 0? Assumption.
UE is, yeah, we are taking approximately 0. It's not real. I told you it's an approximation. It's not real value.
Okay.
Why this is selected? Can you check all the terms on the right hand side in this? Can you check all the terms
Yeah.
on the right hand side? Everything is constant.
Constant. Yeah.
So if a person going to purchase a microscope, you can simply calculate how much is the power approximately. Is it possible with this formula? Check down this formula.
Because there are variables like VO.
D and F are constants, but VO and U are not constants. Then he has to do the experiment in the shop and do what is VO and UO. That's not practically possible. So this is only an approximation just for the practical purpose. We never use it for any calculation.
Okay, sir. So, but they can ask to derive, right?
Yeah, they can ask you then from this you can get how to increase the magnifying power. Tell me what in terms of you can do to increase the magnifying power.
Length,
FO and FE.
length of tube
Yeah, length to
increases.
be adjusted, right?
Yeah.
It's
And
fine.
then FO can be decreased.
Yeah.
FE can be decreased.
Yeah, that's why we wrote in the beginning first, short focal length both, right?
Yeah.
Yes, sir.
It comes again. But don't use this
So-
formula for any calculation. Only this
Okay,
one
sir.
to be used for the calculation. Okay.
So can we say like this is the direct substitution of what we found in the previous case, where we've taken VO by UO into VE by UE, and then we substitute 1 plus D by FE directly?
If you don't remember at all, go for that because that case we proved for two lenses in contact.
Yes, sir.
Here the lenses are out of contact, so you can't use the same formula here. We have to prove that first once more.
Oh, okay.
If the lenses were in contact, you can use directly because we already proved that for two lenses placed in contact.
Yes, sir.
If the lenses are out of contact, so you have to get the result once more.
Yes, sir.
If no
So, and how
options
is
you
UO
don't remember at all, you can use, but mark will go.
Yes, sir. So, and how is UO equal to FO?
It's not equal, it's an approximation. You see, you kept the object beyond focus, right?
Yes, sir. We kept to be on focus.
You can push this again little more towards right. What will
Yes,
happen?
sir.
This light ray will go straight, same, no difference.
Yes, sir.
But this light ray will go little more down. The image will be formed here, like big.
Yes, sir.
So
Because it's closer to the optic center.
Yeah, practically you can keep O very close to F.
Yes, sir.
So FO can be approximately same as what UO, not exactly.
Yes, sir.
This top result, you don't worry, it's an approximated result. I told you just to get a rough idea about the device.
Yes,
This
sir.
one should be clear to you till here, and this is the approximation based on that.
Yes, sir. Got it.
So the diagram, it's fine to you how to draw from image back to the object.
Yes, sir.
So this is second case then, if you're okay with this.
Yeah.
Second case,
Yes, sir.
image formed at
Far point.
far point. What difference will come compared to this? Image is
So
formed
the
at
light
far
rays
point.
will be, the final light rays will be parallel. That means
Okay.
light rays exiting C2 and FE. I mean,
Yeah.
exiting the islands. And
Yeah.
Yeah, so image will be formed. Sorry, image of the first lens will be formed at the focus of the other lens.
at FE.
Yeah, that's the point. Image formed by the first lens, which act as the object for the second lens, should be at its own focus.
Yeah.
When the object is at the focus, image will be formed at far point. Can you draw the diagram?
Okay.
Okay. So you want me to go back image to the object or object back to the image?
Image back to object.
So can I leave this page? It's fine with you?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
New page. See, if it's okay, still no any confusions, I'm waiting. There's no problem in that. You can ask and make it clear. Yes?
Shani sir, in this case, in far point, there is no image formed. So
There is no final image you see. The light rays will be parallel.
yeah. So how do we trace back?
It's the same like
from
the
image.
last
No,
case.
you trace back, but just that it doesn't join.
Yeah. You see the simple microscope, the second case, just check diagram.
Yeah. Yeah.
Yes.
Yes.
We are drawing now. I'm going to the next page
Yeah.
then, okay?
Yes, sir.
Principal axis. The first lens. The second lens. So here you told me the light rays go parallel, right?
Yeah.
So I'm just not keeping any image. It won't be formed. So I can just draw one light ray enough passing through C2.
Okay.
Now the second light ray
is parallel to the
again
first.
parallel. So I take another point and draw parallel. It's fine.
Yeah.
Now what's the next step? Tell me.
So then you should draw the image, like draw it parallel to the principal axis,
Yes,
where
correct.
it means you draw the image or the object for the eye lens.
Yes. You're following what I'm doing, right?
So I'm drawing
Yes,
my
sir.
own diagram.
Yeah. Then I should make this dotted line before, like.
Yeah.
Then the same method back. What you should do?
So I have one doubt.
Yeah.
So in this case, it's far point, right?
Yeah.
So the object for the eye lens is at focus.
Yes.
So here we need to get it as exact same, right?
Yeah, it will be coming. If you draw parallel, it will be this distance will be same exact. You can check. From here to this point will be same as from here to here. So then I mark that one. This point is called FE, right?
FE.
Parallel light ray. And this
So it
point
came
also
same.
FE.
FE. It will come perfect.
Yeah.
And even that point is IM, okay? So I'm calling it as
Yes.
I. Because there's no second image here. So just only one from IM. And what is this distance? This distance.
UE.
Yeah. This distance is UE. And where is VE? VE is formed at infinity, right?
Yes, sir.
Then what should I do from M? Direct me.
So you have to draw a ray through the optic center.
Okay. Then
So and one more ray from the same point.
yeah.
And then draw the parallel line.
Yeah. I think you've got it now, right? The idea is clear
Yes,
now.
sir.
So I drew it. It's nice.
Yeah. This is the easiest way I feel. I don't know how you feel, okay? You never get
So
a
it is
mistake.
very easy. It's nice. Yeah.
Then can you mark this point will be O, B, then this distance will be what will be the distance?
U.
U. Then from here to here,
VO.
what's the importance of UE in this case? That's equal to
25.
FE.
why 25? I don't know that still 25 coming here.
Oh yeah, yes, yeah. Sorry.
What?
So UE has to be equal to FE because
Yeah,
the image has to be
okay.
formed at infinity.
Yeah. Why 25 comes here?
So
Why
because
it came
because
25 in the beginning? That's the
always
question.
think when we have to rearrange.
That's okay. Why you told me 25 in the beginning? That's the question. That's I understood what you're telling. Why?
So I didn't
Why?
get the question.
Okay. Final image at far point.
So V is infinity.
Yeah, V is infinity. Image is formed at far point, right?
Yeah.
Now this is C1. This point is C2. The properties of the lens remain same, okay? Objective lens and eye lens.
Yes, sir.
Yeah.
Can you try the derivation?
Yeah.
So I got HI by HO into D by FE.
Did you reach the final answer?
So I'm getting there.
Yeah.
So I think Kevin got an answer.
Yeah, can you direct me then if you got M is equal to?
Theta by theta.
Okay.
Shani, sir?
Yes.
So don't you transfer the object to near point?
Yeah. So tell me first, where is theta O and theta I?
So theta I is I C to N.
Yeah. Theta I.
So theta O I took it as B dash C to O dash. I transferred it to a near point.
Okay, so I have to draw another line here, right? Down.
Yeah,
Yes,
yes,
sir.
sir.
So I'm drawing another line from here, C2. till near point. Near point, I'm taking any point my wish, okay? Because there's no near point in the question. This is a near point, and I'm transferring the object to that point. The object will become O dash B dash. Then draw the line from here. So if you mark the points, this will be O dash.
By C2 dash.
This will be B dash. And this distance will be
D.
capital D. And this angle will be
Theta I.
Theta O.
Theta O, sorry.
theta O.
Yep.
Then if you substitute here, what will come?
So I am by C2I.
Yeah.
I am by
C2.
C2I, yes.
Into
By O dash B dash by D.
into C2 into
C2O
C2 O dash by O dash B dash.
I didn't listen once more, please. Into
So into C2 O dash
O dash?
C2 O dash
By O dash B dash.
O dash B dash, correct.
So C2 we can take as FE, right?
Yeah, we'll do last. Fine. I'm just writing that.
Yes, sir.
Yeah, next step, you can substitute the values. What is IM by, I'm just rearranging again. But IM by O dash B dash is same as OB, right?
Yes, sir.
Yeah.
Then multiplied by what is left?
So C2 O dash is D.
D.
By F.
Which F?
So FE.
So F.
FE.
FE. It will be careful, and there are two lenses, okay? F for FE.
Yes, sir.
Now, what is IM by OB actually?
HI by HO.
HI by
That's
HO.
magnification.
So linear magnification.
Yeah. Then it can be VO by
VO by U. Minus.
yeah, minus will give sign convention last. So with sign convention will be minus. That's the result. Then you can do the approximation. Approximation. What was approximation? Same.
L is equal to
VO
VO plus
approximately equal to L.
Yeah.
U approximately equal to FO.
Okay. So the result will come as.
L by FO into D by FE.
Okay. Don't use it for any calculation. Okay.
Yes, sir.
So when do we use this equation in questions?
We
Like
never
when they
use it.
give-
This is
They
for
ask
just to
you.
get an idea for you how much is the power.
Yes, sir. Okay.
If you go to buy an instrument, you should know how much you want, whether it's serving your purpose or not. Only for that.
Oh, okay. Bless you.
That was a sneeze.
I I heard it like that.
Can you check and tell me it's fine? So that with this microscope part is done then.
Yes, sir.
That's
Yes,
fine.
sir.
It's fine, sir.
It's getting more clear once you do the topics like 1, 2, 3, 4. Now 4 case over.
Yes, sir.
Okay. Then we have telescope. I'm waiting if you're doing, if you're done.
So finished.
Done, sir.
So done.
Do you want to go discuss numerical questions now or go and finish the telescope and come?
So I think we'll
So-
finish all the practical the theoretical part of this chapter. Then we can go to numericals.
Okay. So then I'm moving to the telescope then. Okay.
Yeah.
Yes, sir.
Yes, sir.
Telescope normally used for,
Viewing far objects.
okay,
Distant objects.
far away objects like planets,
The moon,
moon,
Stars, planets.
stars.
our neighbor.
Yes.
Yeah.
So
Yes, sir.
do they really form a magnified image in length, size?
No, sir.
See?
They form a
No,
smaller
no,
image,
sir.
but because of the angular magnification produced, it appears to be
It just
larger.
brings the image closer.
Okay. So that's clear to you.
Yes, sir.
Yeah.
So telescope just forms, or it's used for observing. It's an optical instrument used to observe distant objects with angular magnification. There is no linear magnification.
Yeah.
Linear magnification is less than 1, right?
Yeah.
Yes, sir.
Okay. But it gives us a feeling it's larger because the angle subtended is
Brought
small.
closer.
Yeah, closer.
Yeah.
Now telescope, we have classifications. One classification telescope, we call it as,
Refractive, reflective.
yeah, one is
Where they use the lens or mirror.
refracting telescope, where objective, not the whole, okay, objective lens, objective is a mirror, concave mirror, because convex mirror never form magnified.
So refracting is convex lens, right?
Okay, this is for refracting, right? This is better. I
Yeah.
change reflecting. Easy, right?
Okay.
Then I'll come back to the next one. And the second type is what I told in the beginning, right?
Refractive.
That is the refracting
Telescope.
telescope, where objective is a convex lens. Yes,
Yes, sir.
this is one classification. We see what are the advantages of reflecting or refracting on the way. One type of classification. The second type of classification,
Astronomical and terrestrial.
this classification is based on objective. The objective will decide the name, whether it is reflecting or refracting. The other classification depends upon the use. Use means observation is done on terrestrial objects or astronomical. So the first classification in that category comes as astronomical. This is for observing
Celestial bodies.
celestial bodies. And the second class is called
Terrestrial.
terrestrial. That's for observing objects on Earth. This is a classification just to understand how the telescopes are called reflecting, refracting. or astronomical and terrestrial. Now we again have two lenses for a telescope. We'll go for the case one. I think that's better. That will tell you directly what happens. Telescope, we do the first case as the far point. Telescope. Final image. We do both anyway, doesn't matter.
Shani sir, for telescope, is U always infinity?
Yeah.
Objective lens.
Yes.
Okay.
Final image at far point. Even before that, you should know the properties of the objective lens. There are two lenses.
Yeah. Objective and eye lens.
This is the principal axis. The first lens used is much larger in the case of a
Telescope.
telescope. Why? Because
to gather more light.
Yeah. So the image will be
brighter image with more resolution.
So more clarity.
Yeah, clarity. That's two cases. Like, so I'm noting here. Objective lens. Property number one, large aperture. Large aperture for
Objective lens.
yeah, why?
So for brighter image.
Yeah.
So it increases the power.
No, brightness, right?
Okay.
Aperture, not focal length.
Yeah. Okay. Yeah.
Brighter image.
That's for islands.
As it collects more
More
light.
light.
Then, not only that, you need large focal length. Normally, the other case it was short focal length, right?
Yes.
Yes, sir.
For
This is
higher
large focal
magnification.
length. The reason will come from the derivation last. Or I can try in a different way if you want. Otherwise, it comes at the end of the derivation.
So you can do the derivation. We'll find out from that.
Yeah. Then, what about the islands?
It's
Eye lens
short.
is shorter aperture compared to objective lens.
Yeah, because
Give larger power.
yeah, why the islands has to be short in aperture?
So because when light ray passes through objective lens, the light rays get converge, so they move inside. So the eye lens needs to capture it. If it's large, it is fine, but it will waste money.
Yeah,
It'll be
no
more
need of
expensive.
because the objective lens forms a very small image for far away object, right?
Yeah.
Yes, sir.
Small aperture, then short focal length. Short focal length because it acts like a simple microscope again, okay?
Yes, sir.
So short focal length give you large magnifying power.
So are we using large focal length because it forms a small image for eye lens?
I can try that. Can you just check here? I'm trying different way. We get a result from that. What's the magnification for a lens normally? M equal to V by U, right?
Yeah, V by
Yes, sir.
Okay. Can you change U when you observe the moon?
No.
No, that's fixed, right?
It's fixed. Yeah.
And it's very, very large.
Yeah.
And you know, when
So we take it
object
as
distance is very, very large, close to infinity, the image will be formed close to focus.
Yeah.
Yes.
Yes, sir.
So I can change this formula as F by U. Why?
So because image will be formed at focus.
Yeah, almost focus. So how to increase the magnifying power?
By increasing focal length.
Large focal length.
Yeah.
That's the reason. Fine.
Yes, sir.
Yes, sir.
I cannot change the object distance from Earth to Moon, but I can use a convex lens of large short focal length to get V more or less. You follow?
Okay.
Yes,
Yeah.
sir.
Even you don't understand, it's coming at the end, another derivation, okay?
Fine, sir.
I'm removing this one. We are doing which case? Image at
Far point.
far
Far
point.
point.
So I have to draw the second lens. Second lens is small compared to the other one. Here also it's better, easy to draw you if you keep the image first. I'm keeping the image first. I'm drawing close to the eye lens. Why?
Should
Because
be
object is from infinity.
at focus
At
of
focus.
We know
eye lens.
objective
And
has
the
to be
eye lens
large
has
focal
short.
length, right?
Yes, sir.
Yeah.
And the
Eye
image
lens has
formed
short
by
focal.
the lens will be at the focus when it's at infinity.
Yes.
So if you
So
draw
then
this,
that means FO and FE will be in the same point, right?
yeah, correct. So the length will be F4 plus FE then.
Okay.
The length L equal to F4 plus FE means this distance will be
FO.
It's VO but equal to F4, right?
Yeah.
And this distance
Is UE but is equal to FE.
VO equal to F4 and this distance will be UE but equal to FE.
FE.
Now, see, you don't want to draw this first, but this will make the work easy. I have drawn very close to the
Islands.
islands. Now, one light ray should come through the optic center, right?
Yes, sir.
Yes.
One light ray comes through the optic center. Then one light ray should go through the optic center again, right?
Yeah.
Now you want parallel light rays. Why parallel light rays?
Because images should be formed at far point.
Yeah, formed at far point. The light is also coming from far point.
Yeah.
Yes, sir.
So I draw a line parallel to the principal axis like we do before, touching the tip of the image. Then I can make it parallel. Be parallel
Yes,
here.
sir.
Here also it will be parallel.
Okay.
So this is the incident light ray number 1. This is the incident light ray number 2. This is also number 1, number 2. Again number 1, number 2. If you want to draw this extended, you can say this extended so that we say the image is formed at what? Extended back.
Far point. Okay.
Then keep it rubbed like dot. Fine.
Yes, sir.
Okay.
Yes, sir.
This can be the rule. Passing through focus will become parallel. Okay. See.
And through optical center.
Yeah. Through optic center and passing through focus can become parallel. Can you mark theta I and theta O?
So theta I will. So you've not marked the.
Yeah, I'm marking. I M
And C2.
C1.
So that's IC2M is the image. I mean theta I.
Theta I.
theta I.
And
So C1 is theta O.
Yeah, what is formed at C1? For telescope, theta O will be with object at infinity because we cannot
Yeah.
bring the
Objects always at far point. Yes, sir.
theta O. If this is theta O, this also will be theta O, right? Vertically opposite.
yeah, that's correct.
Yes, sir.
Then same you can get done.
Yes, sir.
Theta A by theta O.
Substitute the values.
So you will get
IM by
IM
IC2
by IC2.
into IC1 divided by IM.
Yeah.
C2
Into C1I.
yes. You're taking reciprocal, right?
Yeah, we are taking reciprocal.
It will be C1I
By IC2.
by IC2.
Can cancel.
So you get FO by FE. Or
Go, right?
So minus FO by FE.
How come IC2 comes? Okay, how come IC2 together?
So no.
oh, so
it's not
IC1, sir. So the
IC
second one. So the second one is IC1 by IM.
yeah, I am.
And that'll get cancelled, sir.
Yeah, it's IM. It gets cancelled.
Correct. So it will be IC2
So
by
C1
Minus FO by FE.
IC1 by
C1 by IC2.
IC. That's equal to FO by
O by FE.
FE.
So it is also equal to VO by UE, right?
Yeah, VO by UE, but VO is F1, UE is FE, right?
Yes, sir.
Yeah. So this minus sign because image is upside down. For
Yeah.
C2I is measured left. Okay.
Yes, sir.
For magnitude of M, that's only we use for calculation equal to FO by FE. Now you can tell me how to improve the magnifying power.
So short focal length
Short
of
focal length.
Objective and
islands.
yeah. Short focal length objective and sorry, eyepiece and
Larger focal length of objective lens.
Objective lens.
what about power?
So it increases.
Short focal length means what? Large power.
Large power.
Short focal length, high lens, and large focal length means small power. Objective. Increasing the magnifying power. If you're done, what's the difference for the second case? You're not done, I'm waiting for you.
So the answer.
Done, sir.
So what should we do now?
Yes. You want to ask any clarification based on the derivation of the concept?
So it's clear.
So from this, can you tell me how why we need shorter focal length for islands?
It will not will be
So
the
is it
concept of the result. This one?
okay? Fine.
Yes.
So lesser Fe will give you greater magnification.
Larger.
Yeah. Okay.
We'll move to the next or still have
So it's clear.
So in the near point case, the only difference is that the image is formed at a point.
yeah.
It doesn't go till infinity.
Yeah, you made okay, fine, correct.
It's formed
It's formed at near point.
at right.
Where the object for the second lens still. Where should be the
So
object lens?
infinity. Oh, islands. Okay. Focus.
The focus only
No. Yeah.
No, so between focal length and
Between
optic
C.
center.
Between F and C2.
That's a concept.
Fe and C2.
Final limit is infinity, object has to be at the focus. The final is just near point, you have to keep the object within the focus. Okay.
Yeah, between
Yes.
F and C2.
So this won't coincide now. FO will not coincide.
Yes, sir.
Yeah.
FO will go inside FE. Okay.
Yeah.
Yes.
Yes, sir.
Yes, sir.
Can I move to the next diagram then?
Yes, sir.
Principal axis. Lens 1. Lens 2. I'm drawing the final image, okay?
Yes, sir.
Final image. You can draw anywhere. I'm drawing here, final image. We mark it as IM. Virtual. So what we follow, you remember first case what we did?
Yeah.
From M?
You draw through C2.
Yeah.
Through C2. C1.
So if you draw through C2, you go like this. Then from same point, and right? No? Yes?
So I
Yes,
didn't
sir.
hear you.
Yes, sir.
I'm waiting for you to tell me what to do next.
Okay. the second line, from that vertical axis, you draw a parallel line which meets the first line, and that point will be the where the object of the eye lens is placed. Yeah.
No.
You can draw a line passing through C1
C1.
from the top. And the second line, which
Parallel
is
to the
parallel.
principal axis, strikes the objective lens and
Yeah.
then passes through the focus of the objective lens.
Should be parallel to the emergent ray.
Practice 1 or 2 times at home with this rule. I think this will be very fine then.
Yeah.
Try to rub this lightly, okay? It's not correct. Where the parallel light ray pass to the focus is F.
Yeah.
If you mark
FE.
that much measured depth and still be within the focus, you can see. C2
Yeah.
to FE measure and mark, it will be within the focus, right? The image.
FE.
In this point, like we mark I1, M1. Then UO is infinity. What is this distance?
VO.
VO.
But that's equal to
FO.
it is infinity.
FO.
Means. U equal to FO. And this distance
UE.
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 And this distance
VE. Minus D.
objective lens. Theta O and theta I.
So theta O is C1, angle C1.
C1, yeah.
Yeah. So through vertically opposite angles,
Yeah, correct.
you
Same
can
as
get it on the other side. Yeah.
I1, C1, M1.
yeah, then theta is
C2.
then we'll go for M.
0.
So I1 M1 by I1 C2
C1. Yeah, I1 M1
by
by
I1 C2
I1 C2 into
I1 C1 by I1 M1.
taking reciprocal I1 C1 by I1 M1. I1 C1 by I1 M1. So we can cancel.
M1 will
So
go.
FO by UE.
After cancelling, we'll get I1 C1 by I1 C2 is equal to F4 by U.
If we check this answer, UE is not a constant.
Yeah. So we
Yes,
can
sir.
use lens formula.
We're going to change that. One by
VE minus 1 by UE. 1 by FE. Divide by V. They multiply into V.
So here you just want 1 by UE. Let's check.
So
F
take
is right?
1 by UE
to the other side.
right hand side. 1 by FE. Okay.
That's enough. Okay.
Okay, fine.
You
Yes,
just
sir.
two in one.
So F4 into 1 by VE minus 1 by FE.
F4 instead of 1 by UE, it will come as. Here I wrote something wrong.
1 by V. No. So FO into 1 by VE minus 1 by FE.
1 by VE
VE
minus.
1 by FE.
They want 1 by FE common out from that.
Then multiply FE to 1 by divide FE. So 1 by FE
Divide
VE.
1 by VE, right? Both. F4 by FE. And FE will come
Then
out.
FE by VE minus 1.
Now substitute VE as minus V. Last.
So minus F4 by FE
Yeah.
into 1 plus FE
FE
by
by D.
D.
Minus whole minus 1. So minus will come out, right?
Yeah.
Since all are constant, we don't want to go any approximation.
Yeah.
So how did Fe by D, minus D become D by Fe? Like the reciprocal?
That's wrong.
Shouldn't it?
Fe by D.
By Fe by D.
Thank you. I was thinking about the old formula, D by F.
Yes, sir.
This is a little longer than the previous one because you had to do this adjustment last.
Yes, sir.
Yes, sir.
Now the derivation,
Which,
I have to tell you.
so
on,
which case is this?
this is
Near
Near
point.
point.
There is image formed. See the diagram?
Near point.
Yeah.
Shani sir,
Yeah.
I have a doubt, but like it's more related. It is related to microscope.
No problem.
So when we view the microscope, at times we see our eyelash as well. Sometimes when we view through the microscope, we can see our eyelashes.
Okay. That because the lens is a glass, right? Transparent glass. It can reflect the light rays back to you. Like
Oh, okay.
when we see the glass window, we only see the things outside. Sometimes we can see our reflections also.
Reflection.
Some
Yeah.
of the
Yes,
light
sir.
get reflected back. To act like a mirror
Yeah.
partially.
Oh, okay. Okay. Thank you, sir.
So, but not always, right?
Yeah, that depends which angle you look. If you look straight, mostly
Like the intensity and the angle of the sunlight. I mean, the light.
Not
always
intensity.
the more intense one will be
No,
dominant.
like depending on how bright it is.
Yeah, depends upon like now if we keep a light on and sunlight is showing its image much clear compared to the other ones.
Yes, sir.
Lighter one will show its image more clear.
So, and I had a question about the telescope. So, like in a microscope, we have certain cases wherein we can increase the like amount of magnification, or like we can change the place where we're looking at it from to increase the clarity of the image. So, what's there in the telescope other than like increasing the length of the telescope?
Actually, when you told me, I remember I forgot to say one point. We wrote large aperture, right?
Yeah.
Last
Yes, sir.
case. What was the reason for that we wrote?
To gather more light.
Okay,
Yeah,
that is one
sir.
reason, right? There's
Yes.
one more reason, but actually it should not come here because we study later only. But that time maybe we don't remember. We just write and leave. Large aperture help to increase
Increase
the
resolution.
resolving power. It will add, okay, that's the reason. Resolving power basically means clarity of the image. Like more pixels in the camera.
Oh.
The camera is more pixel, the image taken with that camera will be much clear compared to the less pixels camera.
Yes, sir.
It's better if you go to Biolab anytime get a chance, keep a white paper with a line drawn on with a ball pen. You see under a microscope, you don't see it to be a single line, you only feel it to be a collection of points.
Yeah.
Because actually there's a gap between the two dots, the ink.
But it's very minute.
Yeah, but you can't see with the eye.
Yeah.
More clarity will tell you this is a real gap. Don't use ink pen, okay? Ink
Okay,
pen, the ink will spread and fill the gap. It will be continuous. Only use a ball pen.
Yep.
That's the meaning of clarity. So large aperture can help in increasing the clarity of the image, means the resolving power. That's what I missed over there. And Sarangin, what you're telling just now?
So like we have many features in the microscope that help us increase the clarity of the image, right? Or like help us see what we want to observe.
Okay.
So in a telescope, other than like increasing the length of like, so I don't know what but like the main body, there's the part where you increase the length of the telescope, right?
Always for both microscope and telescope, if you're
Yes,
done
sir.
microscope, there's a wheel, turning wheel called rack and pinion adjustment. By turning that, you can adjust the distance between the two lenses.
Oh,
Have you done microscope in biolab by increasing a rotating small wheel like
Yeah, on the side.
yes, sir.
side that will adjust the length between the objective lens and the eye lens? That can help in forming the image more clear, focused image.
Yes, sir.
Both cases.
So
Telescope
it's
is much
even on a
longer.
telescope.
Telescope is much longer than microscope
Yes, sir.
because focal length is large, right? What's the length here? In this case, what's the length of the tube? This particular piece.
So FO plus UE.
Yeah. That's needed for the numerical question. Okay, FO plus. It's fine.
So how is it FO plus UE?
CFO, where is FO? C1 to image, right?
So yeah. Okay, fine.
DO is same as FO, okay?
Yeah.
And UE, not FE.
Okay.
This is fine. Now we have to learn what are the advantages of a reflecting telescope over
Refractor.
Refracting telescope.
Any more questions on this, or it's fine?
So could you repeat that, please?
Which case? I didn't see any case. I told you we have to learn the advantages of reflecting telescope over refracting telescope.
Yeah, yes, sir.
Can you see this page? No. You're
Yes,
seeing
sir,
screen
no.
only.
We can see the screen.
You can see this?
Yes, sir.
The diagrams.
Yes, sir.
I'm going through the pages, or you're only seeing the paint.
No, sir,
No, sir,
we can see the pages, sir.
So what you do in a reflecting telescope, you're replacing the objective lens by a large concave mirror.
Yes, sir.
The
So these are
advantage,
advantages of reflective over refractive, right?
sorry, yeah, reflecting, this one, reflecting over refracting.
Yes, sir. Thank you, sir.
The basic advantages are one, for a lens, large aperture lens practically means 10-meter diameter, like that large. 10-meter means your classroom. If you remember the classroom, you come here, it's only 3.5, that much only, almost the size. So 10-meter diameter means larger than that. So it's
Yes,
hard
sir.
to construct such large lenses because central part of the lens is thick and outer edge is thin for a convex lens. Relatively, it has to be thick at the center and thin at the edge. And for a lens, you can't hold anywhere other than the edge.
Yes, sir.
It's very heavy. So construction, keeping it in position, mounting and operation
It's difficult.
is very
And
difficult for
maneuvering,
a
yeah.
large aperture convex lens. But if you see a mirror, mirror is a very thin envelope. You don't want to be thick at the center, thin in the edge, like. So the weight will be very less. Even full back side of the mirror, you can use support system to control the mirror because backside is opaque. So because of that, we prefer one advantage, concave mirror instead of convex lens as an objective. So construction, mounting, operation control all easy for a mirror objective compared to lens objective. Yes.
Yes, sir.
Yeah.
And when light passes through a convex lens, the glass lens will absorb light. The light coming out will be less compared to the light entering the lens. Like a room, you have a glass window. The light entering the room is less compared to the light falling on the window.
Yeah.
So in a mirror, almost all the light will be reflected without any absorption. Again, the brightness of the image can be improved by using mirror objective instead of lens objective. Yes.
Yeah. Yes.
So in refractive, what we're saying is that more light is going out, whereas less light is being refracted or towards the surface.
Means the light passing through the lens, what is coming out of the lens will be always less compared to the light entering. Absorption will take place inside the lens.
So refraction occurs in a mirror.
Refraction, no, light won't pass through, right? It just only touch the surface and reflect back.
Yeah.
So there's no possibility of light getting
refracted,
absorbed.
Yeah.
So that's two basic advantages of reflecting telescope over refracting telescope. Can you see this diagram? Now it changed.
Yes,
yeah.
Sir. Yeah.
Okay. Now, when you use large aperture lens, there are two lens defects basically. You can see white light is splitting into 7 colors when it's thick.
Yes.
And if it's a large focal length lens, this will be splitting much more, right? This is showing here only, this much splitting. The focal length is very large, the splitting also will be more. So red will be here, violet will be here. So instead of getting a white single image for a white object, you get colored images.
Okay.
So this defect of a lens, because of thickness and large aperture, it's called chromatic aberration. Chromatic aberration means forming colored
images
for a white object. This only happens in a lens because lens only disperses the light. It never happens in a mirror.
Yes, sir.
So you can avoid the possibility of
chromatic aberration by using
aberration if you use mirror as objective instead of lens.
Okay.
Yes.
Yeah.
Then one more, something called spherical aberration. Even for a large aperture lens, if single color is used, all the light rays will not converge to the focus because the distance is large for a 10 meter, 15 meter diameter lens. The light rays will converge at different points. The lens will not be able to convert all the light rays to same focus. You can see the diagram for a mirror. There's no diagram for the lens. This you can see the first diagram. The top light ray has large distance converging. The axial ones close to the axis less distant, they're converging little far away. So the convergence is different for light rays coming from
different points of the mirror.
Parts of the large aperture mirror.
Yeah.
Or in the case of a large aperture mirror. So lens, you can't change the shape of the lens. Focal length will change.
Yeah.
For a mirror, you can make the mirror more curved like this, so that you can have a parabolic concave mirror by adjusting the top and bottom more curved. So almost all the light rays have same distance to the focus. But
Shani, sir,
yeah.
So chromatic aberration can be avoided if you use a thin lens, right?
Yeah, but still large aperture will make the light ray deviate, right? Still.
Yeah, that is it.
Yeah, but that will be less compared to the thick lens. True.
Yeah.
If you use a parabolic mirror, you can reduce the effect of spherical aberration. You can't avoid the spreading. Here you can say spreading is more. How much spreading here between these two? Here the spreading is very less.
Yeah.
Yes, sir.
So using a mirror objective, you have basically 4 advantages. Chromatic
So,
aberration
but
never happens.
spherical aberration occurs in mirrors, right?
Yeah, spherical aberration occurs in mirror and lens. But
Oh, and
mirror
lens
you
as
can
well.
bend.
Okay.
The mirror shape you can adjust to reduce the effect of
Yeah.
spherical aberration.
But
Yes,
you
sir.
cannot do that for
Lens you
lens.
can't do with adjusting the shape.
Yes, sir.
So these are the 4 advantages, and you should know how to draw the diagram for this. It's called Cassegrain reflecting telescope.
Yes, sir.
This is the objective mirror. The light rays are coming from infinity parallel. They are converged to the focus. They're supposed to focus here. So this is a 10-meter diameter objective. So a person can simply sit and see the image here with the eyepiece.
Yes,
Only
sir.
to make a platform here. But that will obstruct the light ray passing through the center. We don't want to do that. So we arrange a small convex mirror almost close to the focus so that all these converging light rays approaching the focus can be reflected back to a point behind the objective mirror through the hole at the pole. This is a small hole at the pole. And you can see by keeping the eyepiece here. So it won't obstruct the light rays much. By adjusting the eyepiece, you can form the image to be far point or near point.
Yes.
This diagram is not perfect because they are shown large convex mirror. Okay, what you should do, you should draw all this very close to the focus and draw a very small convex mirror.
Yes, sir.
Extend this light ray till focus point and just draw a curve just before the focus, very small curve. So it won't obstruct the light rays much.
Okay, sir.
Yes.
Shani, sir.
So, but for reflecting, you said it was a concave mirror, right?
Concave mirror is the objective mirror.
Oh, okay. Yes, sir.
This is for
This is the
just
eyepiece.
reflecting the light rays back.
Yes, sir.
Yeah, that's.
Yes. Aditya.
So, periscope is an example of reflecting telescope.
No, periscope, we only have reflection. There's no image large size in that. Just we use normal
okay.
mirrors.
Yeah.
So you don't have a magnification in that case. You can have a magnification using periscope, using adding telescope into that.
Okay. Okay, fine.
So this,
Can you
yes,
can you upload this file on the WhatsApp group?
WhatsApp
there on
group I
Teams?
can't do. You send me a mail, I'll forward you.
Sorry,
Siddharth,
sir?
is there on Teams?
WhatsApp group, the problem is my phone get stuck after some time. This much big files, so much you do like.
Okay, sir.
You send me a mail, I'll forward you. No problem.
Okay. Okay, sir.
Okay. I have a scanned copy of the book, like this page, this chapter.
Yes, sir.
Siddharth,
Yeah.
it's uploaded on Microsoft Teams.
Like, oh, okay, on the group. Okay.
Yeah, class.
Yeah, class
On the
file.
tuition group.
Yeah, I'll be deleting that
Yeah.
group. You can check before that, okay? Not today. Because that create maybe issue sometimes later. That's why.
Yes, sir.
Okay, sir.
So can you check the numerical questions and check any theory confusion so that we spend at least the next class only on the numericals?
Okay, sir.
Yes, sir.
Yes, sir.
Fine.
So we
Yeah.
yes.
Okay, I need your help in completing the work and asking the doubt. That's very important. Okay.
Yes, sir.
Sir.
Finish there.
So,
Yeah.
is there any more? Finish it.
Sorry.
Did we finish the theory? Or
Yeah, this chapter theory we finished.
okay.
Nice.
So next class we do the numerical questions.
Okay, sir.
Yes, sir.
Okay. You have to go through the full chapter. Keep the doubts, anything left. Try the numerical questions. If that is done, we'll do some questions. I'll select question wise which all question to be done. Okay.
Okay, sir.
Yes, sir.
Okay, sir.